In today's world, there is an overflow of information. Okay, we all have access to information through various medium, and there's loads of information out there, which is good, right? It's good to have information. However, what I find is with an overflow of information comes misinformation, as people misuse words or terminologies intentionally or unintentionally. I would say unintentionally. I don't think someone would intentionally misuse a word, right? But again, I don't know what people's intents are, so we would say intentionally as well. Either way, as people misuse words or terminologies, the information can become a misinformation. Now, this misinformation is quite dangerous, because what it does is it turns clarity into confusion and knowledge into misdirection. Now, why do we take in information? To help us learn. Information provides clarity in certain subject, on a certain subject, and it also gives us knowledge, right? Now, once we are not careful with how we use terminologies and we misuse a certain terminology, what happens is the information, the clarity within that information becomes confusion, and the knowledge we're supposed to get from that information becomes a misdirection, ultimately leading to disinformation. Okay, now disinformation is a very scary thing to spread out there. As we know, in our world today, one of our biggest threats is fake news, which is disinformation. Now, for us in the technology space, and I'm speaking to myself as well, this is a factual or fact-based space, okay? And so we should be careful on ensuring we do not misuse words or terminologies within the space. Having said that, I would say hi and welcome to Technical Jargons 102. This is the second episode. Can you imagine? Second episode. This is the second episode in the Technical Jargon series, where we address misuse of words or terminologies within the technology space. So let's dive in. Today, we will be addressing one buzzword. This buzzword has been around since, I would say, late last year, and is not dying down soon, right? It's been said that this word, this terminology, is the future of artificial intelligence, right? Which is true. I agree with that. But we need to understand it properly. And the word is agents. Okay, if I get £1 for every AI agent tutorial on YouTube alone, I'd probably build my own AI robot, and I won't have to do this video myself. So we will be talking about misuse of terminologies around agents, right? There are there's a main type of agent that we all talk about, which is called the AI agent. But there are also types of agent that I hear people misuse, which is also the LLM agent. Now, the advancement of AI, especially the recent advancement of AI, was only possible due to the advancement of building large-scale language models. Okay, so LLM is at the forefront of AI agents as well. So what I tend to find as an AI engineer, and I say I'm also guilty of misuse, so this is a way of us being aware of it, right? Is I see that people sometimes refer to both, mention both when referring to the same function or system. So people use AI agents and LLM agents interchangeably. Now, what is an AI agent? That is artificial intelligence agent, right? And what is an LLM agent, which is large language model agent. I will say this for a fact. They are both, right, useful and are core to the advancement in AI technologies, but they are different. They are different in design, they're different in function, and they're different in use case. So in this episode, I will be addressing the difference between an AI agent and an LLM agent. And I'll also explain to us other types of agents that we can have within the space. Okay? As usual, I think that format worked. I used it in the first episode as well. How we're going to tackle this is I will be telling us what they are, so defining them. I'll be defining what an AI agent is and an LLM agent. 2, I'll be telling us how they work. And 3, I will be telling us how they are being used. Finally, 4, I would also be telling us how they interact with each other. That is, an AI agent and an LLM agent, how they interact with each other. Okay? So, stay tuned as we dive in. Hi, and welcome back. Artificial intelligence continues to transform our world. That's a fact, okay? Now, AI is reshaping industries and driving innovations in various sectors within our industries. Healthcare, banking, finance, marketing, gaming. In all these sectors, AI is driving innovation. And how is it able to drive innovation? Through AI-driven applications. So AI-driven applications is how we can use AI technologies to transform our world today. Now, what are AI-driven applications? Now, AI-driven applications are applications built on AI technologies. Okay? There are still software applications, the standard software application. Now, the difference between them and an AI-driven application is that AI-driven applications are built on AI technologies. At the core of AI-driven applications are AI agents and LLM agents. There are other types of agents. I will talk about them in this video. However, because today, as of now, most of the AI-driven applications we have rely on LLM agents. LLM agent is part of the core of AI-driven applications as of right now. Okay. Now, AI-driven applications are built on AI technologies, and AI agents plus LLM agent are at the core of how it processes AI-driven tasks. Now, what are agents? For some of us who have been working in this technology space as an engineer for a long time, we have built agents before the word agent was coined. Okay, so they were simply called functions or systems. Okay, so to keep it simple, I would say if AI agent is a system, LLM agent is a function. Okay, so that goes into us defining what an AI agent is. Now, an AI agent is a software system or entity that is designed to autonomously, independently perform tasks by perceiving its environment, reasoning about its environment, meaning thinking on it, and also executing or performing tasks or taking actions based on the decision it's made from the reasoning. So I'll say that again. AI agents are software entities that are designed to autonomously or independently perform tasks by perceiving the environment, reasoning about the environment, and taking actions based on decisions made during the reasoning process on their environment. So the reasoning process is where they make a decision. The decision made is then what triggers the action they take to be able to perform the specific task they've been designed to do. And they do all of this independently, autonomously, meaning without human intervention. Now, I did say that the difference in an AI agent and an LLM agent is by their design, function, and their use case. So we're going to go to the design. The design of an AI agent is composed of four main components. So we have the perception component, the reasoning component, the action component, and the memory. So I've added memory to it. And the reason why is I find that most engineers don't plan for the memory in advance. So the memory component is important to the entire process. Okay. Now, what happens in the perception stage? At the perception stage, that's where the AI agent collects the data that it's required for performing the task. So that is the entry point where it gathers all the data required. Now, it can gather the data required from external data sources or through a prompt or user interface or input interface. But the perception stage is where the AI agent is gathering all the data or information it requires. So that is where it's learning about its environment. Learning about its environment really is it's gathering information about its environment. And that's what happens at the perception stage. Okay? Now we go to the reasoning stage. At the reasoning stage, that's where it processes the information it collected at the perception stage. So that's where I would say this again, because most of what we do is mathematical in engineering. So that's where it develops a mathematical representation of the data that it has access to. I do speak fast. That's where it processes the data it has access to by generating a mathematical representation of it. From that, it's able to identify patterns and relationship between that data. Once it's able to properly understand that data by identifying the patterns and relationship between the data, then it fully understands its environment to be able to make a decision. Remember, AI agents make decisions independently, and it happens at the reasoning stage. So the reasoning stage is where it processes the data to be able to make a decision. Then we go to the next stage, which is the action stage. At the action stage, what it does is, because it's able to make a decision from the reasoning stage, it then executes on that decision. So it executes the action required. So that's what happens at that stage, right? So there are different technologies required for each stage. There's a different technology for perception, for reasoning, and for action. I will go into that briefly in the video as we carry on. So the final stage to talk about is the memory stage. At the memory stage, it doesn't come after the execute stage, so it's not it doesn't follow like the way I've explained perception, reasoning to executing. Memory is important in all three stages. So all the three stages, right, or three stages require the memory, and it's that stage where the AI stores and retrieves information to help it get better and making decisions to perform the task effectively. Okay, memory is key for an AI agent. It needs to be able to store its data and have a way of retrieving that data to help him make decisions properly. And it happens at all the stages, especially during the reasoning stage, because at the reasoning stage is where it's making a decision. Okay, so a quick recap. The design of an AI agent, right, is built on 4 components. All right, that's easier. Perception, reasoning, action, and memory. All right, okay. Because every other word didn't sound well to me, so I like to keep things simple so we can follow. So simple English is key. All right, so 4 components make up the design of an AI agent, which is perception, reasoning, action, and memory. Okay, now we go to the large language model agent. Now, the large language model agent is designed to perform a specific task, which is to process natural language to be able to understand it, generate it, and interact in it. So, LLM agents are built to be able to generate dynamic content, understand natural language, and interact with it. That's what they're built for. So they have one specific task. Okay, so they use large language models as their reasoning engine. So if we're going into the design of that, they're designed primarily for natural language. So don't forget that. So everything within the design of it is for natural language. And what does it do with natural language? It generates it, well, it understands it, and generates it, and then interacts with it. Okay, so let's go into the 4 components. Before that, I'd like to also say that I did mention in the beginning that if AI agent is a system, LLM agent is a function. Remember, I said LLM agents are built for a specific type of task. AI agents are built to be able to perform all types of tasks autonomously. So if AI agent is a system, LLM agent is a function in that system because it's a specific task on natural language within that system. So in the diagram that is on screen now, you would see an AI agent. I don't know why it sat like this, but you see it there, and then you see all its function, and then you see the LLM at the top. It's one of the tasks. When it requires using or performing any task on natural language, you use an LLM agent. So that's how they interact. Okay, so going to the design of an LLM agent. Just like the AI agent, it also has 4 components. I think I tried to make it 4 so it's uniform or consistent, right? Not all its 4 components are required by default, and I will explain. But let's start with the first component, LLM. LLM as a model is the brain of an LLM agent. So that's the first component in its design, the LLM. The reasoning engine of the LLM agent is in the LLM model. Again, by its name, okay? We can have an LLM agent without an LLM model in it, okay? So an LLM agent requires an LLM for its reasoning model. All right, so once you are able to understand that, you know you cannot build an LLM agent without the model. And the work of the model is for it to perform reasoning. Okay, so that's the reasoning engine of the LLM. The next component is prompt engineering. That is very key. You cannot get an LLM to reason without giving it information on what it needs to reason on. So prompt engineering is the instructions you give to the LLM on how it should perform the reasoning. And there are different types of prompt engineering. You can look at it online. So there is, I'll give us a few, I won't go too much into it. So there is zero-shot prompting, which is you giving the LLM an instruction without an example. So you can ask it, you can say to it, what's the word? Can you tell me if the weather is going to be hot tomorrow? Answer yes or no. It will just give you an answer yes or no. You don't have to give it an example. It's clever enough to be able to do that. Okay, so that's zero-shot prompting, meaning zero prompting, zero examples given. Okay. Another type of prompting within the prompting technique is what we call few-shot prompting. Now, I've always struggled with that because sometimes it's several shot prompting. There's a lot of examples we give to it. So few-shot prompting means we're giving it examples. Few examples or a lot of examples, but we call it few-shot prompting. So that is when you're giving it examples to follow, say, to better guide its reasoning. Say, you give it a type of examples saying that, okay, I'm looking for an example. Write me an article on AI agents, for example. And then you go, an example of an answer to that question would follow this format. You tell me what an AI agent is, and you tell me how it's being used. Once you explain that way to an LLM, it then will provide the answer using your example question and answer that you've given to it. Now, I didn't give you an example, a good question and answer example at the minute, but that's what just came into my head. Just understand that few-shot prompting requires you giving it a similar question and a similar answer, and then it uses that in its reasoning to provide answers to your questions. Another type of prompt engineering that we have is chain of thought, where you give it a structure of how it should follow its own chain of thought. Another example, or another type of prompt engineering is what we call react prompting. This is where you teach it to reason and act. So you would have a structure of how it should think, it should reason, give it how the thought example. There's a structure to follow. I'm not going to go too much into it because that's beyond this episode or this video. But react prompting is another type of prompting. So prompt engineering, as you can see, there are quite a number of different types of prompting that you could give it, is very key to getting the LLM to reason and make a decision. Okay? Now, people have said, if we can get an LLM to reason through prompting, right, why do we need a reasoning LLM? Again, let's not go further than that. Reasoning LLMs are good for more complex tasks beyond standard prompting. Okay, as you can see, GPT, DeepSeek, and the likes have reasoning LLMs, right? They help you without you having to write a full React prompt or chain of thought prompt to guide your LLM. But if you still want to do normal, complex tasks, but not overly complex, using standard LLM, you can use prompt engineering, and you can use any of the React or chain of thought or few-shot prompting to do that. Okay, so that is another key component within the design of an LLM agent, prompt engineering. Now, another one I've added to it is tools. Tools use is a component, meaning the ability of the LLM agent to use a tool. It's key in the component design, not because LLMs can directly use tools. LLM can't directly use tools, but they can generate code that you can pass to a tool to use. For example, I built an AI tool that requires getting data from a database. So what my tool does is it takes the user query and converts it into an SQL code. Of course, I'll give it the schema of my database so it knows how to write the code. Then it outputs this SQL code that I can pass to my database to run the query. So that's how an LLM agent uses tool. So it can use tool to act as well. Okay, an AI agent acts differently. Okay, there's action, it executes its own action through other types of tools within it, which we will go to. But for an LLM, it doesn't use tools directly, but it can generate code or input for a certain tool that you may be using. Is that clear? All right, so the final one is what I call the memory simulation. That is a key component in LLM agent design. Now, LLMs cannot retain memory, so they can persist information. So they need a way to be able to use information or prior information to be able to answer your next question. Right. So I did a design early last year on memory simulation. Now, in this image that is on screen, it's something I used to explain how the memory of an LLM operates. Okay, this was early last year before we got to agents. Right, but it's useful for today. So in that, you would see that I have three types of memory that I've explained in there. So there is a stimulus memory, which is the user input. Now, LLMs are good for receiving information through an interface. So that's a user input. That user input, say, tell me if the weather tomorrow is going to be hot or not. That is information that forms part of his memory, but it's called the stimulus memory, right? Or I call it a stimulus memory. The other type of memory within an LLM agent is what I call prompt memory, also called short-term memory. Now, when you're talking in a chat bot, right, there is something called the chat history, which is the history of your conversation in that chat. Now, it is important to let the LLM know the history within the prompt, else it's just going to hallucinate or just say nonsense when you ask it a question. I'll give you an example. An example is, let's say I ask the LLM, tell me the top 5 destinations in the world today. It's going to give me, say, I'll give an example. I hardly go on holiday, but let's say Marrakesh, Maldives, Santorini, Greece, I don't know, all of that. Now, further down your conversation, so it's giving you top 5 holiday destinations in the world. Now, further down in your conversation, you can then ask it, tell me the top 5 restaurants in the first destination. Now, if you don't pass the history to the LLM, it doesn't know the first destination. It's just going to tell you nonsense. It's going to make up a destination for you, and that's where the hallucination comes in. Okay, so when you pass the history to it, which is the prompt memory or the short-term memory, it then sees in your historical chat, oh, the top 5 has Marrakesh, and Marrakesh is the first one, so I will give the top 5 restaurants in Marrakesh, and that's how you get the answer. Right? Now, the last type of memory is what I call the long-term memory. Now, this is not, depending on your use case, it is not required by default. Okay? And the reason why it's because it depends on what software or what application you're building. If your application is a domain-specific application, you can give it a long-term memory through what we call a RAG approach, which is retrieval augmented generation, where you pass a context-based data to the LLM to help it ground its understanding so it only answers from a domain-specific data set. Now that is a long-term memory. I've called it a long-term memory. I think some people also refer to it as long-term memory. So memory simulation is a key component within the LLM agent. Okay, so let's recap. AI agent design has 4 components: perception, reasoning, action, and memory. LLM agent also has is designed on 4 main components. LLM as its brain, prompt engineering as its reasoning structure, tools that it could use to act, and memory simulation. Okay, I hope that is clear to follow. So you can see that their designs are different. Now we would go quickly to how AI agents work. How do they work? Now AI agents are built on a broad framework. Okay, now the broad framework means that they have various approaches in ensuring that they can perform their tasks independently, meaning without human intervention. Right? So there are various approaches that they rely on to be able to perceive, reason, and act. One of the approaches is using standard programmatic function or code. Right? Now, not all tasks require AI technology. Right? AI technologies are good for complex tasks. But if you have a task that is narrow-based, so a narrow-based task, you can still use your standard programmatic function or code. I'll give you an example. If you need a data within the AI agent processing, and that data can be got from an API or a separate data source, you can just write a standard function to call that API, get the data or the value, and use it. You don't need an AI technology for that. AI technologies are good for repetitive tasks that also require a large volume of processing, right? For simple tasks or narrow-based tasks, you just use a standard programmatic function or code. Now, AI agents use this approach for their simple or narrow-based tasks. So within the overall task of an AI agent, there are subtasks, and each subtask requires the appropriate approach for it. So for narrow-based tasks, use standard within the AI agent. You can use standard programmatic function or code. Okay. Now, another type of task within an AI agent is a task where it requires processing natural language. Can you guess what approach is going to use for that? An LLM agent. Okay, so an LLM agent is another approach that it uses to perform natural language specific tasks. You see, so within an AI agent, you can have AI technologies and non-AI technologies with it. Okay, so we've seen that it can still use standard programming function or code, and also it uses LLM agent for natural language based tasks. Okay, so LLM agents help the AI agents to leverage LLM in generating and interacting in natural language. Okay, so you can see that LLM agents are often integrated within an AI agent in how it processes or does its task. right? Now, not all AI agents require LLM agents. So depending on what your AI agent is built for. But for the purpose of this episode, this is me showing you that an AI agent also requires an LLM agent if it has a subtask that requires natural language processing. Okay? Now, other approaches that it can have is, say your AI agent requires, say, image classification, face detection, or face recognition or object detection. You can use a non-LLM agent called computer vision model agent, right? So there is a computer vision model, which is an AI model separate to an LLM model, which is a large language model. Now, that model can be used to perform any image detection or object detection within, or image classification function within the AI agent. So as you can see, AI agent is a broader framework that uses all types of agents, not restricted to LLM agents. And it can or cannot. It can use an LLM agent or may not use an LLM agent, depending on what it's built for. So an AI agent is a broader framework of agents. So when we say agent, really what we mean is an AI agent. Where I think the confusion comes in is because most of our AI-driven applications right now are built on LLM agents. Or built using LLM agents, because a lot of our advancement is around LLM at the minute. People tend to, especially when they get to the natural language task within that AI agent, they then refer to the entire AI agent as an LLM agent, and then when they pass that, and then go to, oh, it's an AI agent. So that's where the confusion comes in, where the AI agent and LLM agent are used interchangeably to refer to a certain system. No. The natural language task within it requires an LLM agent, but it is not an LLM agent overall. It's still an AI agent. And as I've shown here with the classification function or image classification function, we have other agents that it can use that are not LLM. So you have the computer vision agent model. Another non-LLM agent that it can use is the reinforcement learning agent. So remember, within the design of an AI agent is the reasoning component. The reasoning component benefits a lot from a reinforcement learning agent because it helps its decision-making process. Right? It's also sometimes called a decision-making agent. Remember, within an LLM agent, there is it uses LLM as its reasoning engine. It's not the same reasoning as what an AI agent does, because an AI agent has to do a lot of agent orchestration within it to be able to make the right decision. Okay, so reinforcement learning agents are actually key in building the reasoning agent of an AI agent. Right. Now, another good use of a reinforcement learning agent is if your AI agent requires robotic controls, you can use a reinforcement learning agent for that as well. So that is a non-LLM agent as well. Another non-LLM agent that can be in an AI agent are the autonomous system agents. So the ones you find in, say, like self-driving cars or drones, for example. Now, say, for example, a self-driving car in itself is an AI agent. And within that, it uses other agents like computer vision, that's what I want to say. Computer vision agent, sensory detection agent, and also reinforcement learning agent, right? So you can also have sub AI agents within a larger AI agent, right? So basically you're having, like I explained simply in the beginning, there can be functions within a function, so sub-functions of a bigger function within a bigger system. So you can keep building on your agent as required. But an LLM agent is designed for just natural language processing. An AI agent is a broader framework that may or may not include an LLM agent, depending on what the specific goal of that AI agent is. Whew, that was a mouthful. I hope that is clear. Okay, so let's go to how they are used. Right now, use cases of an AI agent. I will start with saying automation, right? Like one of my colleagues would always say, automatizing stuff. So automation is key in building an autonomous system. So when automation is a task required, so when you have a task, looking for the right way to explain this, a repetitive task, right? So when you have a task that requires you repeating it over and over again, and that repetitive task needs to be performed consistently over a period of time, then you would use an AI agent to automate that. So that's a good use case. Another use case is predictive modeling, where you get historical data to be able to predict future data, or what the trend, to be able to draw a trend of activities, right? So you find this in financial modeling as well. So predictive modeling tasks are good use cases of an AI agent. Another one is autonomous system. Like I said, the self-driving cars or the robotics or industrial automations are the types that you'll find in some Amazon warehouses. Yeah, those are AI agents. That's a good use case for that. Use cases for LLM agents are customer support. Okay, because LLM agents are good with natural language, so you can use them where natural language understanding is key, basically, right? So customer support is a good use. Content creation is a good use because it can help you generate text, it can generate reports, generate articles and stuff like that. Another good use case is conversational interfaces. So I just built an AI tool that should go to market soon. It's a conversational AI tool. Conversational AI tool. And these are your chatbots or virtual assistants, and that. So mine is quite domain specific and all of that. So conversational interfaces are good use cases for LLM agents as well. Okay. Now, again, where do we find an hybrid of just AI agents and LLM agents where they both come together? A good example is in e-commerce, right? Where you can have the AI agent, right, perform your inventory management, meaning stock management, adding to stock, updating your stock quantities and all of that, right? So you can have an AI agent doing that. And then you can then have an LLM agent interacting with your customers, right? Where the customers can ask to buy a certain item, and your AI agent can feed back to the LLM agent what quantity of that item is left. So that's a good hybrid of an LLM agent with an AI agent. Now, in this case, I'm not saying the LLM agent is inside the AI agent. They're used separately, but they're created separately but used together. Okay, so the AI agent handles inventory management in the e-commerce site or application, and then the LLM agent manages the customer interaction aspect of things. Okay, another good use case is in healthcare. You can have an AI agent analyze medical data. Okay, and through that medical data, it can generate medical reports. You can then have the LLM agent interact with the patient on their medical information, the outcome of their test, when their next appointment will be, and things like that. So that's where those are examples where they both work well together. Okay, so I hope that is clear. In conclusion, so I hope we understand now how what an AI agent is, what an LLM agent is, and how both of them interact, right, together, and also can work as an hybrid, but being separate entities as well. Right? Cool. Now, in conclusion, I would say, while AI agents excel at being autonomous and being able to perform their tasks autonomously, LLM agent shines brightly in processing natural language. Okay, understanding it, generating it, and interacting in it. So understanding the differences between an AI agent and an LLM agent is key to be able to use their strengths effectively in our AI-driven application. Okay, I think that's all of it in a nutshell, right? So we see now that the terminologies, using them interchangeably, is misleading. Their designs are different, like I have shown. Their functions are different, like I have shown, and their use cases are different. Yes, there are times where they can be used together, or where one can be used inside of the other. So where the LLM agent can be used inside of the AI agent. So that brings us to the end of this video. I hope that is clear. Please write your comments below if you think there is an aspect I've missed. I'm learning every day. We're all learning. I'm open to learning. A mind that stops learning is a dead mind. So feel free to put some more information in the comments below. Let's educate each other. Okay? Thank you, and I'll see you in the next episode. Bye.